Then hello.
Yes, sir.
Hear me?
Yes, sir. I can hear you.
So last day what we have discussed about the recurrence relation, how to solve. Okay. Let the other join that calculate for last class. So in our last class we have uh, discussed the substitution method. In substitution method, actually for a given recurrence, we assume a solution, and after the assumption we try or we actually substitute it to the equation and then prove it that our assumption is correct or not. If not, then we are having some other options that we can go for choosing the lower bound and the upper bound. If these lower bound and upper bounds are correct, then we can increase the lower bound and decrease the upper bound so that we can get the tight bound. Actually, always our target should be to find both the lower bound and upper bound, but it may not be always possible to find both the upper bound and lower bound. So in that case, we should try to find the lower bound. Okay. So let us start today's discussion. The substitution method we have discussed. The next one is iterative method. So to solve the recurrences, we have another method which is known as iterative method, where we will iterate the recurrence till we reach to the uh, terminating conditions, and by getting the terminating conditions we will get the solution. Switch off the microphone. So let us consider one example for the iterative method. After that, we will go on discussing. Okay. So let Tn, someone's microphone is on. Please switch off that. It is disturbing. Someone's microphone is on. Switch off that. So Tn equals to 2T n by 2 plus n. Let this is the equation that we have to solve, the same equation that we have considered for substitution method. So here in iterative method, we will replace this value by next term. So it will be equals to 2T n by 2 means if Tn is equals to 2Tn by 2, then Tn by 2 will be 2Tn by 2 square plus n by 2. plus n. Okay. Next, this n by 2. So here we can write this equals to 2 square p of n by 2 square plus 2 into n by 2, that is n plus n. Next, n by 2 square can be iterated to 2 cube. This one is 2 p n by 2 to the power 3 plus n by 2 square plus 2n, this n plus n to n. So that is equals to, sorry, this is 2. So that equals to 2 cube t of n by 2 cube plus n plus 2n. Okay. So we can write 2 cube t n by 2 cube plus this. So in this way, if we iterate up to n term or ith term, sorry, not n term, ith term, so what we will get? So in the first iteration, we have got 2 to the power 1 t of n by 2 to the power 1 plus n. In the second iteration, we have got 2 to the power 2 plus 2n. In the third iteration, we have got 2 to the power 3 plus 3n. So in the ith iteration, we will get 2 to the power I t of n by 2 to the power I plus I into n. So if we consider that this is the terminating condition, so there must be a termination. All of you have studied this, that there must be a termination. So if we consider that this is the terminating iteration, then n by 2 to the power I must be equals to some constant. Let us consider this is equals to 1. So that implies I equals to log n base 2. Okay, LGN means base 2. So if we replace or substitute this value here, what we will get? This equals to 2 to the power I means n. T of n by 2 to the power I equals to 1. So we can write this is a constant theta of 1. Because this is the terminating condition, it will stop. N by 2 to the power I equals to 1. And the t of 1 is equals to constant theta of 1 plus I log n into n. So here we can write n log n. Now n log n is larger than n. Therefore we can write Tn is equals to big O of n log n. So by iterative method we can find the solution of the given recurrence. So again, iterative means we will just go on iterating the recurrence till we reach to the terminating condition, find the terminating conditions, put the values here and get the solution. So for the same equation, we have got that the time complexity of Tn is order of n log n. Okay. Right. So till now what we have studied? We have studied substitution method and iterative method. Do you have any query up to this? Karam?
No, sir, no doubt.
Okay. So let us move to the next one. Method that we will discuss is known as master method. Okay. So master method is a little bit easier and we don't have to go for so many calculations. Actually, substitution method we have studied that first we have to assume something, then we have to substitute, then we have to prove, then we have to prove the sufficient conditions and all these. Okay. In the iterative method also you have to go on deriving the terminating conditions. After that we have to substitute the value there and we have to get the solution. So master method is a method where we can get the solution by watching or by just getting the relationship between the properties of the constant and the related terms. Just like that, before that, let us define the master method, where it is being said that let a greater equals to 1 and b greater than 1 be two constants, a greater equals to 1, so the value of a may be equals to 1, but b is strictly greater than 1 are two positive constants. Okay, and let the recurrence is given as Tn equals to a t n by b plus f of n. Let a recurrence relation is given as the form Tn equals to a t n by b plus f of n, where this n by b can be bounded as either the floor value of n by b or ceiling value of n by b, because n may not be always an exponential form of b or power of b. Okay, so we can consider n by b as the floor value of n by b or the ceiling value of n by b. So what we are saying that let a greater equals to 1 and b greater than 1 are two constants, b two constants, and Tn can be written as the form Atn by b plus f of n. If this can be written in this form, then Tn can be bounded as number 1, if Fn equals to big O of n to the power log a base b minus epsilon. Epsilon is the power, okay, n to the power log a base b minus epsilon, then Tn is equals to theta of n to the power log a base b. So master method, the first case, there are three cases. First case says that if Fn is equals to big O of n to the power log a base b minus epsilon, then Tn can be bounded as theta of this. Okay. Next, case 2, if Fn can be written as theta of n to the power log a base b, then Tn can be bounded as theta of n to the power log a base b log n. Number 3, if Fn can be written as omega of n to the power log a base b plus epsilon, then Tn can be bounded as, okay, so here if Fn is equals to big omega of, that is the lower bound, is n to the power log a base b plus epsilon, here another condition is with that if and if a into f of n by b is less equals to c into f of n, where c is a constant less than 1. I follow. So for case 3, there are two conditions. One is Fn must be equals to omega of n to the power log a base b plus epsilon, and a into f of n by b must be less equals to some constant c into f of n, where c is less than 1. Then Tn can be bounded as theta of f of n. So these three are the different cases of master method. So let us repeat again the master method. Master method says that let a greater equals to 1 and b greater than 1 be two constants, and if Tn can be represented as a t n by b plus f of n, where n by b is either floor value of n by b or ceiling value of n by b. Then Tn can be bounded as number 1 fn equals to b go of n to the power log a base b minus epsilon. Tn equals to, then Tn can be bounded as theta of n to the power log a base b. If, second case, if fn equals to this, then Tn equals to this one. Here, for the case 2, in some other books, you may get some different form of this, okay? Like this one, that if fn equals to theta of n to the power log a base b log to the power or log n to the power k, then Tn is equals to theta of n to the power log a base b log n to the power k plus 1. In some books, this different form is written, but here we will consider this k value as equals to 0, okay, to the power 0. So this can be proved, and the proof we can also get as an exercise in the book by Coleman. But this is the original form of the second case of master method. Later, after going on so many researches, you may get a modified version of master method. But if we talk about the master method, this is the original form of master method. Later, some modifications are there, but please don't get confused with that. Okay, and don't go for searching the master method in the net. Please read from the book by Coleman or any other textbook. Okay, but do not search the master method from the net, because whatever you will get the updated or modified form, which are considered as the modified form of the master method or simplified form of the master method. But the actual master method or the proof that we will do is on the basis of this one. Check the book by Coleman and others. Okay, whatever CLRST or something people says like that, the first letter of all the names. So we will consider the second case as this, not the modified or some other version. So please don't get confused and don't think that this one is wrong or the other one that is given on the net or somewhere are wrong. Both are same, but the thing is that we will follow this version. Okay. Case 3, if fn can be written as omega of this and the condition a into f of n by b is less equals to c of f of n where c is less than 1. These two conditions are fulfilled, then we can say that Tn is equals to theta of f of n. Let us consider some example, then only it will be clear. Okay. So let a recurrence relation is given as 9 t n by 3 plus n. Okay. So here if we compare this with a t n by b plus f of n, then we can say that a equals to 9, b equals to 3 and fn equals to n. So can we write like this, that fn equals to n to the power 2 minus 1? Now we can write n to the power log 9 base 3 minus 1. So we can just compare this with the first case of master method as n to the power log a base b minus epsilon, where a is 9, b equals to 3 and epsilon is equals to 1. So you can apply the master method for case 1, and we can say that the solution for the given relation Tn is equals to, I think it was theta of n to the power log a base b. So theta of n to the power log a base b, 9. Okay, 9. So that is equals to theta of n square. We can check it by using substitution method or maybe iterative method also. No problem. Okay, you can easily check because 9t n by 3. Next time it will be 3 square, and then 3 cube, then 3 4, and so on. And this value will go on as the same, n plus n or something like that. Okay, or maybe a little more term. You can go on iterative base or you can check it by substitution method that the master method is okay. Actually, we will go for proving the master method in the next class. Then you will find that what are the results that we are getting from the master method are all correct. Okay. But for today, if you have time, or I will suggest that you should consider the theta n square is a solution and substitute this value here and check whether it is correct or not. This is your home task. Right. So let us consider the another method where we can apply another case. So next example, let Tn is equals to T of 2n by 3 plus 1. So it will be always divided as n by 3 by 2. Okay, the input always will be divided as n by 3 by 2. So that is equals to 2n by 3. So here let us find fn is equals to this. What will be the value of n to the power log a base b? Actually, if you go for finding the master method, you can check that the fn value is depending upon, or there is a relationship between fn and n to the power log a base b. Based on the value of n to the power log a base b, the solution of Tn that we are getting every time. Okay, so here for this case n to the power log a base b is equals to what we can get, n to the power log 1 b is 3 by 2. So any base log 1 is equals to n to the power 0, that is equals to 1. So we can write this is equals to fn. Okay, so this is equals to f of n. So here you see 1 is equals to f of n. So n to the power log a base b is equals to f of n, or we can write equals to means same value theta of f of n. So by applying case 2, we can write that Tn is equals to theta of n to the power log a base b log of n. So this value is 1. So therefore the solution is theta of log of n. Again, you can check this value by using iterative method or substitution method. Okay, great. So let us go for another example. That is, let us consider Tn is equals to 3t n by 4 plus n log n. 3t n by 4 plus n log n. So here, what is the value of a? A is equals to 3, b equals to 4. So n to the power log a base b. So this value is less than 1, log 3 base n. Okay. So n to the power log a is somewhere, this value is nearly n to the power 0.8, something like that. Okay, something like that. Now we have fn equals to n log n. Now what is the minimum value of n log n with in terms of n? You see that log 1 is 0, so fn cannot be 0, so we are not considering n equals to 1. Okay, so we are considering n equals to 2 as fn is a strictly increasing function, so therefore fn we are not considering log 1 that is equals to 0. So the minimum value of fn we will get when n equals to 2. So for n equals to 2, what will be the value of fn? Fn is equals to 2 into log 2. So that is equals to 2 into 1 is equals to 2, or we can say right n. So the lower bound of this n log n, the lower bound of n log n is equals to omega of n, that we can write. And if the value of n increases like 3, 4, 5, this value will be changed, but the minimum or increased, but the minimum or the lowest order of n log n is n, and we can write this as equals to omega of n to the power 0.8 plus 0.2, and we can write this as n to the power log log 3 base 4 log 3 base 4 plus 0.2. So if you check the first condition of third case, you can find that fn, which is n log n, can be bounded as big omega of n to the power log 3 base 4 plus epsilon, where epsilon is equals to 0.2. Okay. So first condition is satisfied. Next, what is another condition? That is given as a into f of n by b must be some constant into f of n. So let us check that whether this is true or not. What is a? A is 3. F of n by 4. We should get a constant which is less than 1. F of n means later we will consider. So first, since it is n by 4, so always it will be divided into 4 sub arrays. So the minimum value you can consider this as 4, because if you consider 1, it will be 1/4. So if a sub array contains 1/4 element, it is not possible. That must be a uh, non-fractional term. Okay, this n by 4 must be non-fractional. So therefore we can say that let us consider the minimum value of n is equal to 4. Start with 4. So here we can write 3 into f of 1. Okay. So what is the value of f of 1? F of 1 is log 1 0. So 3 is 0. This equals to some constant into f of n, f of 4. F of 4 means any value that we can get. 4 into log 4, that is 2, 8. So 0 is for any constant must be less than 8. So let us check for another value of let n equals to 16. so that we can get some more value. So n equals to 16 means a is 3, f of n 16 by 4, f of 4 we know the value, that is 8, and let us check what will be the value for c, and this value is f of 16. So whether we should get any value c which is less than 1 or not, that we have to find out. Okay. So 3 into f4 is 8, is c into f of 16. 16 means n equals to 16 and log 16 means 2 to the power 24384. So 16 into 4, that is 64. So here this. So c is greater than equals to, what we can write, 3824 by 64. Yes. So we have got a value for c which is equals to less than 1. Okay, it may be greater equals to this, but since we have to find the value which is less than 1, so here we are getting, if we consider c is equals to 24 by 64, this is less than 1, and this in equation will be okay. So therefore there exists a value of c which is less than 1, for which this 3 into, that is a into f of n by b is less equals to some constant c into f of n. Therefore the first condition is true, the second condition is also true. Therefore by applying the case 3 of master method, we can write the time complexity of given Tn is equals to theta of f of n. Now what is f of n? F of n here equals to n log n. So therefore the answer is, or the solution for the given recurrence is theta of n log n. Okay. So these are the example of 3 cases of master theorem. So let us consider another example, that is equals to our previous one, 3n equals to 2t n by 2. Instead of n, we are considering n log n. So let us check whether this can be or what will be the solution by applying master method. So here what is the value of a equals to 2 and b is equals to 2. So n to the power log a base b is equals to n. Now, is it possible to write n log n as equals to big O of n to the power something like 1, sorry, not plus, 1 minus epsilon? No, because the minimum value of n log n is n, therefore it cannot be written as n to the n minus or n to the power 1, that is n minus n by epsilon. It cannot be written as n by n to the power epsilon for some positive value of epsilon. Not possible. So the first case cannot be applied here, because the value of n log n is always larger than n. Okay, so it cannot be written as n to the power 1 minus epsilon. So n to the power log a base b minus epsilon cannot be written. Next, what we can do, we can check whether n log n is equivalent to n or not. Never, because whenever n is increased, n log n, maybe the lower bound of n log n is equals to n, but n log n is not equals to n, because it will go on increasing this value. Log n is 1, for 2, 4 is 2, then for 8 it is 3, so it will go on increasing. Therefore, case 2 cannot also be applied, because this is not equals to theta of f of n, okay, into the power. Now let us check for the third case. Fn is equals to omega of n to the power log a base b plus epsilon or not. Right. So this is equals to omega of n, that is fine. But here for a equals to a into f of n by b, c into f of n, that is 2 into f of n by 2 is less equals to c of f of n, we will not be able to find any value of c for this. Why? Because n log n is larger than n, but it is not polynomially larger, that n is something plus epsilon. Okay, n log n is polynomially not larger than this, so it will be quite difficult to find for this c. Clear? Therefore, what we can conclude, that though we can find the solution by applying master method for most of the recurrences, but there are some recurrences where master method cannot be applied. So in that case, we have to go for either substitution method or iterative method. Okay, is it clear? Do you have any doubt up to this?
Sir, in the cases where we can find the value of C, will you please show the steps once again?
How we can find the value of c?
Yes, sir.
Okay, so let us again go for checking the previous example. So here we can, so that you can read it by yourself. Tn is equals to 3Tn by 4 plus n log n. You can consider any other example and you can check it. If you find any difficulty, so next day, or not the next day, before that you send a message to me, sir, that for particular equations I am not getting the solution or something, so that in the next class I can discuss it. Okay, so don't wait for the next class. So before that also you can send any message that this equation is not getting solved by master method, or I am not getting anything from this, something, any, if you have any doubt, you just send a WhatsApp message to me, no problem. And it is not required that you have to always send the message to the group. My number is there, so if you have any personal question regarding any particular topic that may not be common with any other friends, easily you can send a message to me, don't hesitate. So let us go for that. So I am not again checking the first case. First case means the first condition, which is Fn equals to omega of n to the power.
Only C part.
Only C part. I am not going to. Okay, fine. So here the second condition is that a into f of n by b must be less equals to some constant into c into f of n. So here what is the value of a 3 and b is 4, right? 4. So we have to find a value of c such that this condition is true. So what is f of n? F of n is n log n. We know f of n is n log n. Here also, right? N log n. Later I will put. So let us consider n equals to 2. We want to find the value of c, that whether there exists any C such that this equation is true. So let us consider n equals to 2. What we will get from the left hand side? Left hand side we will get that 3 into f of 2 by 4. So 2 by 4 means half. Now if we put this value here, log half, there is no meaning. So we are not considering the input size as n equals to 2. Let us consider the input size as equals to n by 4, so that 4 by 4 at least each sub problem consisting of one element at least. Okay. So for n equals to 4, we will get left hand side is equals to 3 into f of 4 by 4, that is 3 into f of 1. Now what is the value of f of 1? Fn equals to n log n,
0.
right? So that is equals to 0. So you see the left hand side is 0. So any value you get in the right hand side must be equals to this.
Yes.
Okay, right. So we are not convinced with this, because right, if we get f of n, that is 4, we will get right hand side is equals to some constant c into f of n, means 4 log 4, which is equals to 8c. So for any value of this must be greater equals to 0, which is not that much of convincing. So let us go for checking for a higher value. Let n equals to 16. Let, okay. So whether we can get any c which is less than 1 or not. For n equals to 16, what we will get? From the left hand side we get 3 into f of 3 into f of 4. We have found here that f of 4 is 8. So we can write this value is 3 into 8, that is equals to 24. Right hand side is some constant c into f of 16. Let us check what is the value of f of 16. F of 16 is equals to 16 into log 16. Log 16 is 4, right? 4. So 16 into 4, 64. So we can write that 24 is less equals to some constant into 64. So from here we can write that C is greater equals to 24 by 64. Okay, so that is equals to 3 by 8. So if we choose any value which is greater than 3 by 8 or equals to, so let us consider C is equals to 3 by 8, which is less than 1. So we have a value of C which is less than 1, for which this condition is true, that what is f a into f of n is log of this. And if you go on increasing the value of this n, let since we are considering 2 to the power n for our simplicity, or 4 to the power n, so next you can consider n equals to 64 or something. You will find that for c equals to 3 by 8, this condition will also be true when n equals to 64. So therefore the value of c is correct for us. In this way we can find a constant value of c. It is not that in the next iteration the value of c will be changed. If you consider this c, the minimum value, this constant is less than 1, then if you consider this value is less than 1, then we can say that yes, uh, for this particular c, 3 by 8 which is less than 1, we can say that a into f of n by b is less equal to c into f of n. So in this way we can find the value of c. Is it okay? Have you understood?
Yes, sir.
Okay. Still, if you have any doubt, actually, uh, this course or this paper is very much theoretical. Okay. And my suggestion is that along with the class notes and others, please go on reading the books. Don't depend on the class notes only. Because what will happen during our class, I may say so many things which are not written on the class test, or not written on the board. So therefore, what will happen if you miss anything? It may create a problem whenever you will go for studying or understanding the same thing after say few weeks. So my suggestion is that you please go on reading the book, prepare your class notes. Okay, I will try to provide the PDF of the class notes. I don't know that whether I have with me or not. I have to check to the department also that whether I have any written documents for these classes or not. So if I have, then I'll supply you the PDF. Okay, but my suggestion is to prepare your own class note. If you need to get it checked by me, you send the PDF to my WhatsApp. If there is anything wrong, I will check it and I will resend it to you. Okay, after checking. So don't worry for that. So for today, we will leave. We will stop. Next day, we will go for proving the master theorem. So before that, again, my suggestion is, or my request to all of you, that you should go at least for studying all this. Okay, so that next day we will go for correctness or the proof of the master theorem. I don't know whether it is in the syllabus or not, but I told the other teachers to include this within your syllabus so that without the proof, it is quite impossible to believe such a theorem. Okay, so we will go for proving the theorem for the simplified case in the next class, or maybe I don't know whether it may take a couple of classes. So we will start it next day. If you do not have any problem, then I will stop the meeting. Should I stop? Is it okay? Do you have any query?
No, sir.
Okay.